So here's our bone, and we have several regions that we wanted to delineate for the bone. We've got a diaphysis or shaft, and that's the central portion of the bone in between the two ends. You'll find that it's largely made up of compact bone that surrounds a cavity called the medullary or marrow cavity. We will look at it in terms of bone marrow and the production of bone marrow here in just a slide or two. At the ends, we have the epiphysis, or if you talk about both of them together, both ends, it's the epiphyses. And the epiphyses will have, hopefully you can see that in this picture, a lot of spongy bone. And the spongy bone will have air and space in between the little fingers of the spongy bone. Now, in between the epiphysis and the diaphysis is what's called the epiphyseal plate. For humans that are earlier than 20, they will typically display epiphyseal plates in regions of their body. I mean, the younger you are, the more plates you'll have. This region is also termed as the metaphysis. So you have the diaphysis, that's the shaft, then the metaphysis that includes the epiphyseal plate, and then the epiphysis itself. So all growth occurs in this epiphyseal plate. Eventually, by the time the age of 20 is reached, then they should be calcified over and will be called epiphyseal lines. Just want to show you a map of the bone marrow, and you can see the bone marrow is present in the diaphysis of bones. And as an adult, the area that's shaded red is going to be the only place that you have active red bone marrow present. As a youngster, it'll be in all areas of the bone. So all the shafts of the bone will have it, and probably the primary bone that we're looking at is the femur. So for kids, we're going to have red marrow everywhere. But what happens to that red marrow as you proceed towards adulthood? Well, it doesn't go away or it doesn't dry up, but it becomes what's called yellow marrow. And why would it be yellow? Because this is where we store fats, the fats known as triglycerides. Remember, one of the roles, the last one we came across was triglyceride storage. This is where it'll be stored at. So we're kind of mothballing, if you will, just kind of storing away this marrow, this yellow marrow. And we can always recall it if we need to. If there's an emergency, this yellow marrow can be converted into red marrow again, but that is a rather extreme emergency. So these areas that are depicted here are just for adults, and the primary area where they're going to lift red bone marrow is from the proximal end of the femur. Flat bone structure is interesting, kind of looks like a sandwich, right? And here we're looking at the parietal bone of the skull, and it looks like a sandwich that has spongy bone in the middle. So now you can see a really good picture of the spongy bone with two layers of compact bone outside it. And so that's flat bone structure, pretty typical. Just think of a sandwich when you do. Up in the upper right's a nice shot of some compact bone tissue that you've already seen from chapter 5. And you can see the ring-like structure of this bone material. We'll be talking more about that in a subsequent video. So bone tissue has a very dense matrix, and that matrix contains what else? Calcium, and it's calcium in a salt form. We'll talk about that in just a sec. Those little black oblong specks you see in the rings are osteocytes, and there are also, you'll see these little darkened structures that kind of look like tree rings, if you will, in between the two, like some osteocytes right in here. We'll see these darkened lines and so forth, and these are interconnections between the osteocytes, and they are formed through canals called canaliculi. The periosteum surrounds the entire bone and protects it. It's a two-layered structure. It has an outer tough, dense fibrous layer where tendons from muscles will infiltrate to connect to the bone. And the inner layer has some very important cells for maintenance of the bone in order to keep it so dynamic. So what are the minerals inside bone tissue? It's made up of two things, these minerals plus proteins. The matrix minerals are all about calcium, And if you recall from chapter 5, the calcium is stored in the form of hydroxyapatite. Whenever you hear those two words, just put them interchangeably because they mean the same thing. And you see the chemical formula for hydroxyapatite. But what's most critical is to know it's got calcium in it. And of course, in bone are matrix proteins. And which one would you think would be the most important? Of course, collagen. You're not going to have elastin in bones. You don't want elasticity to be a hallmark of your bone structure. Okay, onward to video 3.